Hello and welcome back to Differential Equations, section 3.6 on forced oscillations and resonance, which is technically the application of our uh, um, section from last time, where we dealt with undetermined coefficients and variational parameters. So now our differential equation has forcing, and we are going to go from that standard model that we had with constant coefficients, right, with forcing. Now we're going to use mechanical one with a spring. So we are going to use and solve mx double prime plus cx prime plus kx equals to some forcing in respect to time. So our unknown function is actually x in respect to time. And we learned last time that that equation will have solution. If we have those complex numbers, we have the solution that has sines and cosines inside, which we can combine into a single cosine. And that single cosine is actually the oscillation, which is why something attached to the spring keeps rocking back and forth. We calculated the speed at which it oscillates, omega. We calculated the period as well. We calculated the amplitude. So all of that stuff is going to be now repeated, because now we are adding this external forcing, so some kind of a function that is going to act on the system and supply it with with power. So we have again damped and undamped depending on the situation where the motion is happening. So we start with the general equation, and we want to understand that in order for motion, right, to have this rocking behavior, like the back and forth behavior, usually our f of t is some magnitude, which is the force, and then you even have a cosine or sine. Maybe this is the wrong way to write it. Omega 0 t, and well, we can just call it omega t. Omega t, or we can use sine. And I told you earlier, it will depend whether it's a sine or cosine. It will depend which way you set the system in motion and then apply the force. Remember the difference if this is the, actually, let's go this way. So if this is the swing set, right, on the ground, and this is where the kid sits. It's the beautiful thing that in physics you can just replace the entire child with a dot. So if you walk here and push the kid from this position, then it's a sine problem, omega t, because this position here, I mean, right, this gonna be, I need this much larger so I can draw all of the details. We have coordinate system, and this is the 0, which is the equilibrium. So you're going to, let's say, stand here and push the kid from this position. If you do that, it's a sine. So I'm going to switch these two then, since this is the way I wrote, I did the drawing. The other way is to bring the kid out and then launch the kid from there. So this is the equilibrium again in the middle. So this will be the cosine situation. Because your sine graph starts at equilibrium, goes up and down and up and down, your cosine is stretched out first and then let go. You have to observe mechanical concept, right, and figure out which situation you have. Whether it's motion x in respect to t, whether is it pushed from the equilibrium point or it's pulled out of the equilibrium point and then let go. This is the x direction, right, in respect to time, which is the position of the kid. You can draw the same diagrams if you want with the spring, and it doesn't really matter. So the first order of business is to take a look at what we call the undamped forced oscillation, which means we are not going to have effects of air resistance, gravity, friction, all of that stuff is out. So in this case, right, we should have the solution that is stable and oscillates forever without any interruptions. So we start with undamped forced oscillations. And this word here means no C. No Cx prime term. How about that? So equation that we are focusing on is going to be this one, right? Without the C term. And then you can pick either one, either sine or a cosine. It doesn't really matter. We generally go with the cosine, but you can pick the sine as well. All right, so now, what did we learn last time? Last time we learned that the solution for homogeneous case when this is 0 is equal to y complementary was some kind of a C1 cosine omega 0 t plus C2 sine omega 0 t. And omega 0, if you remember, was the square root of k over m. So this is what we had before, and now we are supposed to work this out using either variation parameters or undetermined coefficients, because now we have the forcing, so we need to calculate also yp so that we can have these are not supposed to be y's, this is supposed to be x's. There we go. It's x because that's the unknown function, right? X as a function of t. So we need also the xp because our solution is xc plus xp. So to find this, I'm just going to write here undetermined coefficients or variation of parameters. So this is where the theory from the last time sneaks in, right? But now as the applied problem. So let's take a look at one of these exercises. Let me just find something in any exercise in the homework in the book. The ones that are worked out as examples, you can just read those. Not that exciting. Problem number 4 says that we have x double prime plus 25x equals to, the forcing is given as 90 cosine 4t. Okay, that's beautiful. because I already see a 5 coming in from this side and I see a 4 on this side. That means no repetition. So we can all just go phew, because when it's repetition, right, we have more work to do. Now, x of 0 equals 0 and x prime of 0 equals 90. So this is the problem. And again, yes, this is the motion, right? And we can calculate everything, but we see now the forcing. We see the differential equation on the left-hand side. We solve that one first. Make it equal to 0. We use our r squared characteristic equation from where r is plus minus 5i. And that will give us the x complementary c1 cosine 5t plus c2 sine 5t. My function f of t is 90 cosine 4t. And then when you start taking the derivatives, you get negative 360 sine 4t. Then, you know, when you do this one, you're going to get 360, that's 12, 4, right? 40, I hope. Negative cosine 4t, which gives us xp form of a cosine 4t plus b sine 4t. So these are our standard calculations here. We find x prime, which is negative 4a sine 4t plus 4b cosine 4t, and then x double prime p is negative 16a cosine 4t minus 16b sine 4t. So that's what we have, and now we plug those into the problem above. So we have our differential equation was given as x double prime plus 25 x equals to, what was it, 90 cosine 4t. So now we know that this one goes there and this one goes there. So that's just the standard stuff for undetermined coefficients. So we have negative 16a cosine 4t minus 16b sine 4t plus, and now 25 of the ones above, so that's 25a cosine 4t plus 25b sine 4t is equal to 90 cosine 4t. Cosine and cosine, that's going to be 9a cosine 4t plus 9b sine t equals to 90 cosine 4t. Now we have coefficients of 9a and 90. So a is 10. And this one has nothing to compare to, so b is 0. There is no sign on this side to compare the coefficient with this one, so that's 0. So now we plug this in our xp. So a is the only one that survives. That's 10 cosine 10 cosine 4t. So now I have the solution. X of t is, we had c1 cosine 5t plus c2 sine 5t plus 10 cosine 4t. And we had now our initial condition, x of 0 is 0, and x prime of 0 is something else. What was it? For problem number 4 was 90. So find the derivative, and then we'll compute everything. So that's negative 5c1 sine 5t plus 5c2 cosine 5t. The derivative of cosine is negative sine, so negative 40 sine 4t. Now plug everything in. From the top equation, x of t is equal to 0. That will be c1 plus 0 plus cosine of 0, that's 1 plus 10. So c1 appears to be negative 10. And from the x prime we have 90 is equal to negative 5 c1. No, that term dies because it's a sine of 0. The second one is the one that survives. 5 c2 cosine t. And then the last one dies as well because you have a 0. Right, sine of 0 is 0, and then 40 times 0 is 0. So from here, oh, cosine of t is 1. I was looking what was wrong. C2 is 90 divided by 5, that's 18. So the x of t solution is C1 is negative 10. I'll list that second. So let's put 18 sine 5t minus 10 cosine 5t. Okay. Didn't we have another? Yes, plus 10 cosine 4t. Oops. How's that? I know I have 3 solutions. I didn't write this one, so it's fixed. There we go. So that would be when we have no damping, which means that it will oscillate forever. Now, obviously, way more interesting cases occur when you start introducing damping and all of that. So let's see. I'm looking for another example. There we go. Problem number 8, I guess. It's a new batch of problems. So x double prime plus 3x prime plus 5x equals to negative 4 cosine 5t. We don't have initial conditions in this case, so we're gonna relax there. But we still have to solve the undetermined coefficients. Maybe I should just do variation of parameters just for the hell of it because we can. Let's see what we get first. So r squared plus 3r plus 5 equals to 0. And now we take a look at our negative b plus minus square root of 9 minus 4ac divided by 2a. So this is going to be negative 3 plus minus, that's a 20. And then 9 minus 20 is negative 11. Just want to make sure that I copy the problem correctly. So x, yep, 3, 5, 3 and 5. So we have negative 11 under the square root. Everything divided by 2. One more time to verify. So negative b squared minus 4ac, 4, 1, and then 5. That's a 20. 9 minus 20, negative 11. So we have the complex solutions of negative 3 halves plus minus root 11 over 2I. Now we do have, as you can see, this part which triggers the exponential function in our solution. So xc is equal to e to the negative 3 halves t. The negative is good because that means it's decreasing. And then we have in parentheses c1 cosine root 11 over 2 t plus c2 sine square root of 11 over t. No, square root of 11 over 2 t. There we go, much better. So this is my complementary solution, which we get by simply factoring the polynomial. It's not a big deal. What is a big deal, however, is our situation with xp, and that is coming from here. Now, it is okay to memorize the shortcut because you use it so much, right? At the end, you memorized multiplication tables, you memorized the derivative table, you memorized the integral table. Maybe you can memorize 4 setups that you have seen so far for undetermined coefficients, right? So the immediate response over here is that xp is going to be a cosine 5t plus b sine 5t. So those are that's given, and then we just need to find primes. So negative 5a sine 5t and then plus 5b sine 5t. Then we have the double prime, and now I have another 5 that jumps out. So that's going to be negative 25a sine t and plus, oh no, derivative of sine is negative cosine. So negative 5b cosine 5t.
You didn't do the chain rule.
Oh, kill me now. I dropped the 2, right? Is that it? I hope so. That needs to be 25.
For the first derivative, you didn't
Oh.
switch
Yeah.
yeah.
That's where we need 25s. And this is now 125 over here.
And then it should also be cosine, right?
You have sine, cosine going to sine.
No, it should be 5 and 25.
Yeah. Oh. You know what? you haven't seen me cry yet, and I'm about to begin now. Oh man. Focus, focus. Where's my water? I had the. Give me a second. I got to reboot my brain, not the class. All right. So first derivative. Chain rule kicks out 5. Cosine goes into negative sign. So negative 5 a sine 5t. There we go. Plus 5 b cosine 5t. Going to the next one. 25 cosine t. And then cosine into sine goes negative 25. And then this is a sine. And this is a cosine 5t. And I think we have everything now. So this one goes here. This one goes there. This one goes there. Right, so these are the where they plug in. So let's do that. Now, since I need all of them, let's go. So I just need to write my problem again. That's x double prime plus 3x prime plus 5x equals to negative 4 cosine 5t. All right, so we start with the x double prime, which is this. That negative. Plus 3 times the prime. So that's this. And it has to go in parentheses. And then we have plus 5x. So this is just 5 times this equals to negative 4 cosine 5t. Good. So now what do I have? A cosine and a cosine. B sine, B sine. So let's see. What can I combine? I can combine a cosine with another a cosine. And then b sine with b sine. And then we have a sine and b cosine. They're not going to multiply into anything here. I mean combine into anything. So if we start with the cosine, I have negative 25 plus positive 5, that's negative 20a cosine 5t. And then we take blue terms, negative 25 plus 5b. Don't forget to distribute this one. So that's a 5b, so negative 20b sine and then we just copy the rest because we don't have anything to combine them with. So minus 15a sine 5t minus plus 15b cosine t equals negative 4 cosine 5t. So now you have the cosines even though one is a, one is b. It doesn't matter when you take and divide both sides by the cosine 5t. I've dropped the 5 over here as well, so I'm gonna make sure that's there. So negative 20a plus 15b negative 20 just trying to see if I have all the terms. Okay, so let's go. I'm going to put all of these ones together, cosine 5t, and then we have negative 20b for the sine minus 15a equal to 0. And we just fix this the best we can, and we go from there. So I hope, you know, I looked at this really hard, and I hope that all, you know, worked out. Oh, I don't need the cosine here, it's just negative 4. So now we just need to solve this mess, and hopefully it will work. I'm going to also switch a and b here. So that's negative 15a minus 20b, I believe. So minus 20b minus 15a and then 0 on the right hand side. Okay, I hope this is all good. Let's see. So in order for us to solve this, you can use literally any method you want. I'm going to say that a is equal to negative, so a is equal to put b to the other side, that becomes positive, so a is 20 over 15, but it's negative, so a is negative 20 over 15, and we have our b over here. This cancels down by 5, so it's negative 4b over 3 when you cancel it by 5. So that's what a is, and we plug that into a up there, so negative 4b over 3 plus 15b equals to negative 4. Now negative and negative will cancel. 12 and 3 will give us a 4, so that becomes 16b, I hope. And then plus 15b if we did everything correctly is going to be 31. 31b equals to negative 4. And b is equal to negative 4 over 31. Why is this d now? It's supposed to be b. I hope this is good. So I really don't want to do this again. A equals to negative 4 over 31 divided by 31. No, divided by 3, not 31. Negative 4 times b, which is in our case negative 4 over 31, divided by, okay. Okay, we have that. So now this is going to be multiply two that are far apart. If you want to put this 1 over here, that's fine. So we have that the A is equal to, when we do all of the calculation, that's a positive 16 over 31. So positive 16 over 93. Yeah, I think this is good. 16 over 93. Okay. And now we can write our solution. Oh, kill me now. I forgot how long this is. So our x is x complementary plus x particular. Now what was the complementary one? Oops. So it's 3. So technically this is where the problem goes. The tablet, it keeps jumping. I can't keep up with closing all of the stuff. Okay, let's just put the solution down and be done. So xc is equal to e to the negative 3t, open parenthesis. We do not have c1 and c2, so that's going to stay as cosines. Okay. Cosine root 11 over 2. T plus c2 sine pi over 2. Plus the particular solution. A is 16 over 93. Now where is the particular solution for this one? Here. A cosine 5t. Okay. So A over 3. I put the cosine first, right? Yep, cosine 5t. Finally. And then B is negative 4 over 31 sine 5t. Yep, not the prettiest of the solutions. Maybe not even what you're used to, but it is a solution to this mechanical problem. And from here, right, it just gets harder and more involved. So let's go through this problem from scratch. And then we'll take a look at another concept and then take the break. So when we have now, first problem was the undamped motion. We did not have C. Now in this problem number 8 from the book, I think it's 8. Should be 8. It is 8. So in this problem, you guys have the forcing term to be cosine, and you have the complex solutions, but you also have the dampening, which means it will produce this, which produces this exponential term. Now, what exponential term does is that's the one that shuts down the oscillation. So if you draw exponential guideline, then you can fit the trigonometric function inside, because it will always bounce for e to the x and e to the negative x. So now, when you have the single derivative term, that means that you are stuck either with undetermined coefficients or variational parameters. That depends on, right, what you have. There's not much actually left. They just talk and talk and talk. The damped force oscillation, that's good. Because you already had both examples. So yeah, that's it. Then you have the two examples, and the solution at the end, the one that is boxed in red, is the position function, meaning the object set on this path. Now, obviously, guys, you have to compute these, and those are given by initial conditions. Once you are done with everything and boxed it off, then you remember, right, that you still have to use the other part. Anyway, okay, so why is this weird over here? Sine of root 11t. As soon as the tablet starts overheating, it's becoming, everything is becoming hard. Can't write, can't do anything. Now they do have the word problems where you're supposed to pick up the values for K and C and so on and plug them where they belong. But all of these problems, guys, start with the same equation all the way up on top. They always start with this, and then you might have to figure out which one to use for sine or cosine. And then, I mean, that's if you are modeling the problem from scratch. Now, most of them give you some kind of equation to work with, so hopefully it's not going to be a problem, but I hope you will ask, and then we'll take a look at these. Okay, so let's take a short break, and then after this break we're going to talk about exam again. If you have any questions, concerns, anything. Now again, the part is not streamed, so those of you on YouTube, make your way to the Zoom meeting, and we'll start in 5.